Well, hi everyone. Let's take a look at how the quadratic formula can solve real world problems. Like for this example, a school custodian, Mr. Anderson, is on the roof throwing tennis balls to his students below. Delightful. Okay, so he's cleaning off the roof of the school. Probably I can imagine a math teacher has observed this and then created this delightful problem for us. The first step in any word problem that's like this, that's describing a situation, is draw a picture. Okay, so here is the school. The tennis balls are doing this. Okay, draw a picture, like the simplest picture. Okay, just the simplest thing. Okay, and now here's some things we know. I know my A, B, and C. Here's my A, here's my B, here's my C. Okay, so A equals, we're going to make my little chart up here, minus 4.9. What does that tell me? The parabola opens downwards. Of course it does, because it's an object flying through space. A B is equal to 9.8. That tells me that it's rising here when it leaves the school. And C is equal to 9. That tells me the y-intercept here is the point 0.09. Yes, you guessed it. The edge of the school is the y-axis, and the ground is the x-axis. So we can even label this x for y-axis and y for y-axis, and this is the point 0 in the x, 9 in the y. So that actually answers question A. Mr. Anderson is throwing the tennis balls. I'll do it this way. Mr. A is throwing. Doesn't Mr. A sound like a better math name than Mr. Anderson? Wait, Mr. Anderson, that's Neo's name. Maybe it was Neo. Tennis balls from 9 meters. Okay. Cool. So that's question A. B, find the maximum height of a tennis ball and the time it takes to reach that height. Cool. Okay, so we got to realize that the maximum height is there, the vertex. So if I can find the axis of symmetry, I will find the x value of the vertex. The x value is actually t, time. So this isn't the x-axis, it's the t-axis. And this is not the y-axis, it's the h-axis. But this arose by another name, okay? It's still, in my mind, it's the x and the y. So, b. Let's get started on b. We know we can use negative b over 2a to find the x value of the vertex. In this case, negative b would be negative 9.8 over negative 2 times negative 4.9. And then you plug this into your calculator and find that it equals 1. You want me to prove it to you? I'll prove it to you. 9.8, but it's negative, divided by 2 times, oops, 4.9. It's done it to me. Equals, okay, I need brackets. I need brackets in my calculator, or else I'm doing like the internet troll meme, weird math meme thing. 9.8, but it's negative, divided by bracket 2 times 4.9, but it's negative, and the bracket equals 1. Okay, because 2 times negative 4.9 is negative 9.8. That's how I know. Okay, so it happens at 1 second. And what's the maximum height? So we have to just input here. And I'll use my black pen because I seem to be doing that when I'm finding the y values of vertexes. H at 1 is equal to negative 4.9 times 1 squared plus 9.8 times 1 plus 9. Sorry for kind of writing that in a janky way. This is equal to negative 4.9 times 1 plus 9.8 plus 9. Okay, let's add those together. Negative 4.9 plus 9.8 was positive 4.9 plus 9 is equal to 13.9. So the highest, so let's label our point on our picture, helps guide our thinking. This is the point 1, 13.9. So then we can have a little statement. Mr. A throws the tennis balls 13.9 meters into the air, and they reach this height after 1 second. If you're as excited as I am about that, you can use that many exclamation marks. Determine the time when the tennis ball hits the ground. Don't mind if I do. Don't mind if I do. What I'm looking for here is this point, a root. All right, let's find a root. Okay, how would we find a root? Well, we need our A, B's, and C's, and I've got them up here. Well, I'll do it down here. C is, so my A is equal to negative 4.9. I'm recopying my chart because it's up there. B is equal to 9.8, and C is equal to 9. So then we have the roots are, so T, the time where it hits the ground, will be equal to negative B plus or minus the square root of B squared minus 4AC over 2A. A little German accent crept in there. I wonder where I got that from. So T is equal to negative 9.8 plus or minus the square root of 9.8 squared minus 4 times 4.9, but it's negative, times 9. Okay, that's calculator fodder right there. Over 2 times A, well, that's negative 9.8. Okay, 4.9 times 2 is 9.8, so, but it's negative, so negative 9.8. All right, so T here is going to be equal to, can I simplify those negative 9.8s? Is that going to like blow your brain? Yeah, you're just going to plug this into a calculator. Watch me put it all into a calculator at once. You see me solve so many of these quadratic formulas. I'm going to take shortcuts right now so I don't have to write every little calculation down. Okay, 9.8, but it happens to be negative, plus, oh, and I know that I actually want minus. I'll show you why. Okay, because plus would give me this one back here. It would give me the negative root over there, and I don't want that. I don't want this part here. Who cares about that? That's the land before time. That's the time before we started the stopwatch. Okay, the ball never went there. So 9.8 minus, put this in brackets. Wait, the square root of, oh, it doesn't work. Darn. How do I do that on this calculator? Well, let's do it from the inside out. This is what I'm going to do. I'm going to evaluate inside there, take the square root of it, and then subtract 9.8 from it. Okay, so here we go. Let's do it this way. These negatives can cancel, okay? But what about the square? Well, it's still already plus or minus, so it's both of them, so we can't cancel that. It's both there. All right, so I'm going to have 9.8 plus the square root. Okay, I feel like that's kind of clear, even though you're probably confused as to what I'm doing. Okay, so I'm going to square this. This is, I'm doing inside the square root sign, so that's that. And then I'm going to minus 4 times 4.9, but it's negative, times 9 equals. So that's what's underneath the square root sign. Take the square root of it, is that. Add that to 9.8, which was outside the square root, is equal to this. And then divide the whole thing by 9.8. You will want to write down more steps so that you don't make any mistakes, but I'm very confident that 2.7 is a very good looking answer. It's a very handsome answer. 2.7 seconds. So then we are ready to finish this test. Mr. A's tennis ball hit the ground after 2.7 seconds of hang time. That's a lot of hang time. Not that bad, actually. It sounds very reasonable that he could do that by throwing balls. And then it hits the ground. Okay. So, sketch a graph of the path of the tennis ball, label key features. Notice that that's already done. Notice it's already done. Except we could also put in here, this was at 2.7 seconds? Yeah, 2.7 seconds. We could put this in here. Boop. 2.70. And then finish this parentheses there. There. Now all of our key points are labeled, and we could even draw a picture of Mr. Anderson over here. There, throwing tennis balls to the children below. It said label key features. Seems to me like Mr. A and the children are key features, so I labeled them. All right, so that's how you use the quadratic formula to solve application problems. Any questions, absolutely hit me up by email. Otherwise, thank you for showing up for your learning.